Today we are going to learn the next part of this chapter, motion. That is, the concepts which we are going to discuss today are physical quantities and the system of units here. Okay, so in the previous part we have discussed about what is motion. Okay, that is the introduction part. Okay, now let us see these physical quantities. So what is a physical quantity? Let us see. See here, the physical quantity quantities. So what are these physical quantities? Okay, what are physical quantities? Any quantity that can be measured. Okay, any quantity which we can measure, that we can say is as physical quantity. Understood? So now let us see. Anything that can be measured is called physical quantity. Okay, suppose what is the height of a person? Let us say 5 feet, 6 feet. What is that? That is a physical quantity. If you consider what is the mass of a body or weight of a body, generally what do we say? 50 kg, 60 kg, 70 kg. What are those? That is also a physical quantity because we can be able to measure them. That is a physical quantity. Okay, so can distance be measured? Yes. See, while in a running track, in a running race, we will say that 100 meters track, 100 meters race, 500 meters race, 1000 meters race. Like that, we can measure those distance. So distance is a physical quantity. Yes. Okay, distance is a physical quantity. Now, can time be measured? Yes. How much time it will take for a person to reach from point A to point B? Yes, it will take 1 hour, half an hour. We are 30 minutes, 15 minutes, 10 minutes, we can say like that. So we can measure those actually. Okay, right. Yes, so it is a physical quantity. Time is also a physical quantity. Now, can love be measured? Okay, no, we cannot measure this one because it is not a physical quantity. Love is not a physical quantity. Understood? Because we cannot measure that one. Okay, now let us see. So now what is this? Physical quantities basically are of two types. One, that is scalars, and another one is vectors. Okay, what is a scalar quantity? A physical quantity. We know that physical quantity can be anything which we can measure. That is a physical quantity. In that there will be classification, scalars and vectors. Now what is a scalar quantity? Scalar quantity is that which it is a physical quantity which has only magnitude, which possess only magnitude but not the direction. Okay, it can have only magnitude, but see, magnitude alone, it does not have direction. Such a quantity is known as scalar quantity. Okay, so what is this magnitude means? Magnitude means value or a number. Okay, what is that? Magnitude means it's a value or a number. Clear? Right. Now, when we consider this one, what is this number at particularly? Earlier I asked you, what is this? When I asked you, I told you height 5 feet, 6 feet. What is that 5 and 6? Those are the numbers. So that is a magnitude. When I told you about the mass or the weight of a body, 50, 60, 70 kgs, what are those? 50, 60, 70, those are numbers. That is also magnitude. Understood? So those are all scalar quantities. Next. So examples of that: time, scalar quantity; mass, scalar quantity. Okay, now coming to the vectors. Okay, before we see that, to measure time, direction is not required. So it is a scalar quantity. That is the reason it is a scalar quantity. Okay, right. Now, to measure the mass also we do not need any direction. So it is a scalar quantity. Now, coming to the vectors. Physical quantities which has both magnitude and direction. Okay, it is a quantity which has, it is a physical quantity which has both magnitude as well as direction also in this one. Understood? Right. So such quantities are known as vector quantities. Okay, which has both magnitude and direction. A physical quantity which has both magnitude and direction, those are known as vector quantities. Understood? Let us see the examples. Force. Why the force? See, if I apply 10 Newton force on a table, or if I say 100 Newton force on a table, let us say here, let us say there is a block. Instead of table, I am going to take a block. Okay, so there is a block here. Now, on this block, suppose I said I am going to apply 100 Newton force. Okay, if I apply 100 Newton force on this one, on this block, is it going to move or not? That is my question. What is that? If I apply 100 Newton force on this block, is it going to be moved? Is it going to be in motion or not? What is that? See here, I just mentioned 100 Newton's force, but I didn't mention in which direction. See, if you say with this question, if you say that yes, it will move. If you say it will move, I will say no, it will not move. Why? How? See, I am applying the force in this direction. I said I am going to apply the force in this direction. So that's in this case, if I apply the force in this direction, it is not going to move. So now if you say it do not move, it is not moving. If you say, I will say that it will move. Why? Because I am applying the force along this direction. Okay, we can play with that. So what is that which is missing in this 100 Newton force? Direction. See this arrow representing the direction of the force applied. Understood? So when we apply the force in this direction or along this direction, okay, when we apply the force along this direction or this direction, what happens here? So depending on the direction, the motion is going to change. Okay, in this case, it is not going to move in the downward direction, but in this case, it is going to move in the towards right side direction. Understood? So definitely, in order to express the vector quantity, we need to have both magnitude and direction. So earlier, just now we discussed 100 Newton force along right side direction on this block. See, this is the direction, this is the magnitude. So we have both magnitude and direction. Okay, so force is a vector quantity. Understood? It needs, without mentioning the direction, it is incomplete. Understood? So it is complete only when we mention both the magnitude as well as direction. Understood now? So next, displacement. What is displacement? We are going to discuss now. Okay, to measure force, both magnitude and direction are required. So it is a vector quantity. Next. So now there is a symbol on the doors. Pull or push. We will be observing this symbol all everywhere. Whenever we go to restaurants or some other malls or somewhere, we will observe these things. Pull or push. Okay, so when we are, see what is a push? Push is the force we apply away from our body. Okay, it is a force which we apply away from our body. So here we are having the direction. Pull, it is a force applied towards our body, and it is also having some direction.